All right, so we will go over number 1, and did everybody at least set up the integral for number 6? Because I didn't, there was something wrong with the wording, so I have to change it. This is better wording. But some of us never even looked at it yet, yeah?
But why did it not?
Some of us, look, you guys want a good grade, but you're not willing to do what it takes. Okay,
Why
I'll
would
remember
it
that.
be like you
Huh?
changed the question again?
Well, no, it's the same problem, but I don't know. This is much easier to understand.
Oh.
Okay, so number 1, let's at least set up the integral first. And because somebody came in for help, I took the whole board to do the integral.
Oh?
Did you do the integral? For number 1? Oh, you got it.
Yeah, I got it.
Oh, very good. Took a lot of work, right?
Well, yeah, because I did it the first time. I didn't like switch it X and Y, and so
Oh.
I messed up. I had to do.
And then Kanashiro, no sense asked. Simone, did you at least set up the integral?
I like got to, yes, I set up the first one and then the second, like, I didn't integrate it.
But how do you integrate an ln?
Parts.
X, ln, x, minus 1.
No, that's not that simple.
Yes.
Okay, here's the omega region, and then we have a paraboloid above it, yeah? Anyway, find the surface area that lies above this. So we do a double integral over omega, square root. Now we have z is equal to what?
Y squared.
Okay, so what's the partial with respect to x? 0, right? So you get 0 squared plus the partial with respect to y is 2y, so 4y squared plus 1. And then we're going to do integral, I guess we'll go y first and then x.
Yeah.
So y will go from 0 to x will go from 0 to 1. Did we at least write that integral for 1 point?
Yeah.
Yes.
So only learner did the integral.
I did dx dy, and I did from y to 1.
Oh, does it come out to an easier integral?
Well, you don't have to take the integral of natural log because it's at the end.
Oh my
Oh. But I like doing that.
No, let's do the natural log way.
Oh, that's a good one. Okay, you know what? Just for that, we're going to do it both ways.
That's
god.
not.
If there wasn't a 1, can you cancel the thingies?
And you get 2y.
Yeah, can you? do
Yeah, as
that?
long as over this region it's positive, right?
Oh.
Because otherwise there's an absolute
Oh.
value, yeah? Okay, so if we just did y first, then we would do a trig substitution. So wouldn't that be 2y equal tangent theta, right? So 2 dy is equal to secant squared theta d theta. So we're just going to do this integral first. Oh, I never thought of that. Well, let's do that. So we got the integral square root of tangent squared theta plus 1, and dy is equal to 1/2 secant squared theta d theta. And what are your new limits of integration? Solve.
Oh.
Square root, secant.
Say what? Look at your,
Oh, we're changing.
yeah, whenever you make a substitution, the limits change, right?
0, 2x, no, 2y.
No, you're plugging in the x for the y.
Oh, tangent inverse 2x.
Okay, tan inverse 2x. Okay, so this of course is secant squared theta. Square root of that is secant theta because from 0 to this is assuming that's positive, right? And so well, don't we get a secant cubed integral? And I told you guys to memorize this one, right? Kanashiro.
1/2 secant theta tangent theta plus 1/2.
No. Plus.
That's a plus.
That's what I
1/2
heard.
ln absolute value secant theta plus tangent theta.
Okay? From 0 to tan inverse 2x. So we might have to draw that triangle, yeah? Tan inverse 2x is like this, yeah? Oh, no need, because we changed the limits. Oh, no, but we still gotta do it though. Okay, so we got 1/4. Okay, plug in the top thing. What is the secant of tan inverse 2x? No secant, wouldn't it be this over this? So root 4x squared plus 1. Tan of tan inverse 2x is simply 2x. Plus natural log of, secant again is root 4x squared plus 1 times 2x times, oh, plus, wait,
You don't need it to.
Yeah.
plus 2x. Okay, and then what happens when you plug in 0? You get 0 plus 0. So there we go. So this is what we got. Now we gotta integrate this with respect to x from 0 to 1. So let's put the 1/4 on the outside. Okay, so okay, let's work on this antiderivative separately, so let's do this one. What is the antiderivative of 2x root 4x squared plus 1 dx? What technique should I use here? U substitution, so u equals 4x squared plus 1 du equal 8x dx. So you got the integral of 2 root u, x dx is 1/8 du. So this is 1/4 u to the 3/2. You guys gotta check if I make a mistake here. Right? Plus c. So you got 1/6 4x squared plus 1 to the 3/2 plus c, correct?
Yes.
So that's that one. I'm not gonna change the limits because then I don't know what's gonna happen with this one. Now let's do this one. I guess we could have, but we didn't. Integral, natural log, okay, do we have to worry about absolute value? No, first quadrant. Square root of 4x squared plus 1. Yeah, we did this, I gave this to you on a test. Okay, how do you do this integral? Learner didn't want to do this one. Integration by parts. So u equal natural log, oh, u du, and then dv is the dx, so therefore d is x, right? Now, how do you get du? Okay, Hong, this is u, what is du? Natural log
One.
box,
One.
just one.
No. Square root of 5 squared plus 1 plus
1 over that.
times.
Okay, here, we'll do it like that. Times,
2 plus.
okay, 2 plus. Okay, tell me if I'm doing this right.
Huh?
Like,
How do you get that?
The derivative, oh, come
Oh,
on.
oh, oh, oh.
This is like x to the 1/2, right? So 1/2 x to the -1/2 times the derivative of box, dx. Now, you might think, this is ugly, but if you remembered what we did, when did we do the integral review? Okay, what happens when you make the least common denominator of 2 root 4x squared plus 1 here? What goes on the top?
Four.
Here, I'll give you a hint, that's over 1.
4.
4 root
That being
plus 8x dx.
Oh,
And then, what happens if you factor out a 4 on the top there? Yeah, that's exactly what happened when we did the review. So, you factor out a 4, you get root 4x squared plus 1 plus 2x, all over 2 root 4x squared plus 1 dx. But then, doesn't this cancel that? And that's the beautiful part of it. So you end up with 2 dx over root 4x squared plus 1. Whoa, so this integral is equal to uv, so uv, x natural log root 4x squared plus 1 plus 2x minus the integral of v du. So this times that is 2x dx all over root 4x squared plus 1. Yeah. And then how do I do this integral? U substitution. U equals, let's see if we can squeeze it all in on this one here. Du equals 8x dx. So that's minus the integral. Let's put the 2 on the outside. 8 du over root u. Is that right? So negative 1/4. Actually, I should have put the negative because I didn't circle it. So 1/4 u to the half times 2 plus c, 1/2 root u plus c. So that is minus 1/2, and what is u? Square root of 4x squared plus 1 plus c. Okay, so let's put that there. Where do we have it? What are we doing? Where's the first part?
1/6.
Okay, so wait. So now we got 1/4. Now we got to put it all together. So the antiderivative of this is that, right? So 1/6, 4x squared plus 1 to the 3/2 plus the integral of that is that, correct? X natural log square root of 4x squared plus 1 plus 2x minus 1/2 root 4x squared plus 1 from 0 to 1. Is it correct so far? Plug in the top number. 5 root 5 over 6. Okay, plug in 1 here. 1 times natural log root 5 plus 2 minus root 5 over 2 minus, and then what happens when you plug in 0 here? No, we get 1/6. That would be a mistake. This one is 0, and that one is 1/2. See, it's not 0. Okay, does that come out to the answer on the bottom?
Yes.
Yeah,
How do you know?
Ellen,
Yeah, oh, so just look at that one. Therefore, all good.
and the denominator 12.
What about the constant?
We're good.
Are you sure? Are you even looking at the answer?
4 with 5.
Because what is this? What is 1/6 minus 3/6? I'm trying to concentrate. 1/6 minus 3/6. Negative 1/3, so plus 1/3, plus 1/12 then. Is there a plus 1/12?
Yeah.
Yeah, good. I'll take a picture, please.
Okay. Okay, but now we're gonna do learner's way then. Yeah, take a picture so we can erase. I don't know, I thought that was kind of exhilarating when we did it. Because Dawson came in period 6 and we did it. I said, oh, that's fun.
Let's do Owen's way.
But learner wants to do it the easier way.
Yeah.
Well, let's see.
Is period 6 your only free?
Huh? Huh?
Period 6 is your only free, or was it one?
No, I have 6, 7, and 2 free.
Oh, what?
You say freeze.
Oh, good thing you come in for help. Okay, so learner said integrate with respect to y first. No, I mean x first. So x, wait, why did I erase the thing? So x will go from y to 1, and then you integrate with respect to y, 0 to 1, like that. Oh, that's clever. Well, I don't know, how come I didn't think of that? So what's the antiderivative of this with respect to x? Isn't it just x root, what? 4y squared plus 1,
Wait, how'd you do it? Oh.
right? And then you gotta go from y to 1. So you're gonna, if you plug in 1 for y here, you get root 5x.
Including
Oh, you're plugging in for x. Root 4y squared plus 1 minus y root 4y squared plus 1.
Yes.
And then you integrate that with respect to y from 0 to 1. Yeah, this would be way faster because you just do a u substitution of that. The trig substitution of that is going to give you the secant cube, yeah,
Oh.
which we have. So yeah, you don't have to do the integration by parts,
Wait, where did y to 1 come from?
right? The region omega, right?
Oh, yeah.
So this is like x equal y, and this is x equal 1, right? So from left to right, and then top to bottom. Yeah, well, either way, there's work to be done, yeah, no matter what. And then let us set up the integral for number 6, because the video, I couldn't even understand the problem, so I said, we'll figure it out in class, but I changed it already, so we got it. Didn't I draw this picture yesterday?
Yeah.
But we didn't actually write the integral, yeah? Or did we?
You did.
Are you sure?
No, we-
I don't trust you, Saul. Okay, so if we complete the square, you get x squared plus y squared plus z minus 2 squared equal 4, which is a sphere, center 0, 0, 2, radius 2.
What's the part I think we did.
We set up the integral.
Yeah.
Yes.
I don't remember the 0, 0, 2. I didn't remember number 6 is.
And then that integral was just u substitution, right?
Yes.
Yes.
Okay. We're moving on then. I can't remember what we did yesterday. But Song, your mind is young and fresh.
I'm going through a Joji time right now.
You're going through what?
I'm a hard time.
I
Joji
don't think
time.
it's the integral.
What?
I took notes on everything in the video, but I think like you've done something unusual with that.
Okay, why don't we just set up the integral again then? Okay, so this is, okay, wait. So we have a sphere, right? So if the origin is here, and the center is at 0, 0, 2, right? And then you have the quadric cone. Look, okay, I scrolled already. What was the equation? Z squared over, no. There's a 3 somewhere,
Z squared equals 3x squared plus y.
like that,
Oh, yeah.
right?
Pretty sure.
This was the polar thing.
Okay, so the quadric cone looks like this, right? So when they intersect, it intersects at a circle like this, yeah? So it says find the surface area of the cap cut off by the cone. So it's this upper part here, the yarmulke. Again, we have a yarmulke.
Oh, it's young.
Okay, so first, double integral over omega, square root. Now what we gotta do is, we gotta solve for z. Did we? I don't remember solving for z yesterday.
We did.
I did, okay, but I don't remember. Okay, the easiest way to solve for z, I think, is from this equation here. So, z minus 2 squared is equal to 4 minus x squared minus y squared. Z minus 2 is equal to plus or minus the square root of 4 minus x squared minus y squared. So z is equal to 2 plus or minus the square root of 4 minus x squared minus y squared. But since it's the upper half of the sphere, then we're just doing that then, right? So what is the partial of that with respect to x? 1 over 2 root box times the derivative of box, negative 2x, right? I don't remember writing
Yeah,
that.
we did this.
And then the partial with respect to y, 1 over 2 root box. Well, if it's on the video, times the derivative of box, negative 2y squared plus 1. Okay, and then dx dy. These cancel out, those cancel out. So you get double integral of square root, if we make a least common denominator, like that. No, because it's going to get squared, yeah? So it's just that. That's the least common denominator. What goes on the top? X squared plus y squared plus 1 over, so it's 4 minus, how come I don't remember writing this?
So we actually did it.
Huh?
I can't find it in the video. You just wrote until the first line and then.
See, I didn't do this
That's
then.
right. That's right.
Hey, stop going back and forth. Just take a position and stay with it. I don't, these cancel out. So you get double integral of 2 over root 4 minus x squared minus y squared dx dy. But since we have this quantity there, you probably want to do polar, yeah? So polar going to be 2 over square root of 4 minus r squared, and then you got r d theta. Okay, so what we need to do is, if you have this yarmulke thing and you project it down onto the xy plane, basically you're going to see the circle here, right? So we got to figure out the radius of the circle. So how do you do that? You want to do it geometrically or solve with the equation way? Huh? Geometrically. Okay, we're still going to solve the equation. Okay, so x squared plus y squared is equal to z squared over 3, right? Did we do this yesterday? That I might remember doing. So you can substitute this in for x squared plus y squared right here. Or you can do it in this one. Which one do you want to do? I think that one's better. Z squared over 3 plus z squared minus 4z plus equals 0, right? Multiply through by 3. Z squared plus 3z squared minus, wait, something is wrong here. No, that's right. 12z equals 0. 4z squared minus 12z equals 0. Factor out a 4z. Z minus 3 equals 0. Z equals 0 or 3. So that means these two graphs intersect when z equals 0 and z equals 3. So right here, z is equal to 3 right there. Which means, isn't that 1 then?
Yes.
Right? Because this is, the center is at 0, 0, 2, right? And that's 0, 0, 3, so that's 1. And we know the radius of the sphere is 2. So therefore, what did that have to be, root 3?
Oh.
So therefore, the equation, well, we don't need to write the equation. It's a circle of radius 3 when you smash it down onto the xy plane. So if you're going to do this in polar, r will go from 0 to root 3. And theta, of course, 0 to 2 pi. And that's an easy u substitution integral, yeah?
You always need the positive then.
Well, it's the upper half of the sphere, that's why, right? The lower half of the sphere would be the one with the minus sign. But see how the yarmulke is on the top?
If it was like flat, then would you take the negative?
Oh, I mean, find the surface area down here? Yeah.
Oh.
But then they're equal, right? That area is the same as that surface area there, right? Okay. So these are pretty good integrals we're doing. Okay, so now we're talking about flux. So did you guys look into, like, you know, what is flux? Because I'm pretty sure you guys had A's and 5s on the AP exam, right? For physics.
No.
What?
Phase 1.
No.
Okay, this is what I think flux is. It's like how fluid flows through a membrane.
Semi-permeable.
Anyway, so we have this to compute flux. So this is the actual thing there. What is V? Is a vector field. V is the vector field that the liquid is, or the fluid is flowing through. Dot the unit normal vector of the surface. Yeah, but see, that integral is difficult to compute, so we use this. I don't know who discovered that formula. But that's all you have to do. So why don't we do, okay, there's only 5 problems on tonight's homework. Let's do one of them. Which one you want to do? 1A or 1B? Pick one.
B.
Why? Because B must be harder. Is that it? All right, 1B then. 1B it is. See, with all of this, we still didn't finish early. Okay, let me write down the theorem. So compute flux. The flux of B, B is a vector field across S, which is a surface, right? You have to do a double integral over omega of, what is this thing? That's why you need notes for this test. Negative V1, that's the x component of the vector field, times the partial of f with respect to x. I'm writing it down now because I can barely see it even. Minus the y component of the vector field times the partial of f with respect to y, plus the z component of the vector field, and then you just do a double integral over omega. Okay, so in problem 1b, the vector field is, gosh, I can't, can somebody read it for me? 0,
XZ
xz,
minus XY.
Minus x1.
oh, okay, comma minus xy.
Oh.
And then omega is, oh, come on, look at that simple omega right there. Omega, x goes from 0 to 1, and y goes from 0 to 2. So this is your omega right there. That's weak, but we'll do it. Okay, so we got the double integral of, okay, so what is negative V1? See, this is V1, V2, and V3 right there. So 0 minus V2 times the partial of f with respect to y. Where's f? Z equals xy. So what's the partial of this with respect to y?
X1 is 4 to
Okay, well, let's just do V2 first. V2 is xz times the partial of this with respect to y.
2. It's just X.
Yeah. How did it take that long to do? Plus V3, so that's negative xy. And then you're going to integrate this over omega. Now, which one you want to, since they're both constant, it doesn't really matter which one goes first. Which one do you want to do first?
X.
So if we integrate with respect to x, we go from 0 to 1. And then when we integrate with respect to y, 0 to 2. Yeah, but Mr. Park, how am I supposed to integrate when there's a z here? Well, what is z equal to? xy. So if we simplify, you get integral 0 to 2, integral 0 to 1. So what does this come out to? Negative x cubed y minus xy. Okay, so we're going to do this integral first. So what is the antiderivative of that with respect to x?
1/4.
Negative 1/4 x to the 4th y. I should put the y in the front, yeah? Because that's the constant. And then what's the antiderivative of that with respect to x? 1/2 x squared y, and we're going from 0 to 1. Plug in the top thingy for x. Negative y over 4 minus y over 2. And then if you plug in 0, you get 0. Now we integrate this with respect to y from 0 to 2. Should we simplify this? Okay, so integral 0 to 2, that's negative 3y over 4. So antiderivative is negative 3/8y squared from 0 to 2. Factor out the constant. Negative 3/8, 4 minus 0. So we got 4 goes into 8 2 times. Negative 3/2. Is that the answer on the bottom?
Yes.
I know you don't even have it on that page.
It is,
It is?
yeah.
Okay. Oh, okay, now what does it mean if the flux is negative? Come on, you guys in physics, especially physics C.
What?
It goes out.
So if the surface is here and the vector field is going this way, then it's going that way? The flux? Yeah. I had a D in physics. You guys had A's. I can compute it, I'm not sure what it means. Or maybe you guys gotta ask Doc. Oh, Kaneshiro checked out already. Oh, we're gonna have fun writing comments this time, huh?
Wait,
Kaneshiro dash, checked out, exclamation point, question.
So the, del F over del X, that's like the partial of the,
The partial of F is the function,
okay,
so this is your function right here.
okay, so is that like the surface of S, or,
Yeah, that's the surface of this thing, yeah?
okay,
Because flux, okay, from what I remember, which is not much, something is flowing through a surface, a membrane, yeah? Wait, what are you looking at?
It says flux describes any effect that a disk can pass or travel through a surface or substance.
Wait,
But then it says.
Is this Wikipedia?
No, it doesn't say what the scalar quantity means.
what's the difference between, omega and S?
S is the surface, so Z equal XY, isn't that a hyperbolic paraboloid?
Yes.
It's a hyperbolic paraboloid. Okay, now what is this omega? Then, okay, the vector field is how the fluid is flowing. I guess above omega. Like omega, okay, here's the XY plane, omega is down here. And then the surface is up here like this. And you have a vector field flowing, so you're completely computing the flux, I guess, just over that region. Over the omega region.
Apparently negative flux is just a net flux inward. The positive is outward. And it's like Gauss.
Okay, but if you have a hyperbolic paraboloid, which way is inward? And which way is outward? Oh, that's why you need that end then, the unit normal, because it says the upper unit normal. So the normal vector pointing upward, I guess. So that would be inward? No, that would be outward. And so since it came out negative, it's going to go the other way. I mean, that, you guys are supposed to be good at this. But obviously none of us are. Okay, the main thing is, can you compute it with this formula here? Maybe you guys, when you guys take it next year in college, then you can ask your professor. If you can speak English. Oh, and then look at number 3. Oh, look at that. You're gonna find the mass of a surface. You have a surface of like some kind of metal or something. Yeah, so you gotta find the mass of it. Again, so how do you compute mass of a surface?
Density.
Density times the surface area.
What's volume?
No, volume is when you have like a solid. Remember we did that last chapter? Okay, so when you have a solid, you have a volume, but this is just a surface. A surface doesn't have a volume. So that's why, so you gotta multiply the density function times the surface area.
Support.
Yeah.
Like, is this like a surface? It's a surface, right?
Look here. Okay, okay, a sphere. A sphere is just the outer shell. That's what a sphere is. It's a surface.
Yeah, oh, so it is a surface.
But volume would include everything inside too.
Always.
Yeah, that's the difference, huh?
Okay.
Okay, we are done. So you only have 4 problems to do. How hard can it be?
2 hours.
So, like I said, the last 3 things we're gonna compute. Flux, tomorrow, I think we're doing, I forget, can somebody scroll?
Well, it says the rate of flow per unit area.
The rate of flow per unit area.
That's the scalar.
So like it's going,
How much
what is
flows?
rate of flow? Oh, so like,
Ratio is
it's going through the membrane at a rate of like 5 ounces per square inch
Yeah.
or something like that.
wait, that's what flux is? Not flux is total.
No, I think we're getting the.
But then you guys got magnetic flux too,
Yeah, I
right?
think that's, because magnetic flux is like the,
Charge per unit area.
the strength of the magnetic field times the area. So that makes sense that
Yeah, so it's flux is total.
it's,
Feels like area,
it's B times area. And it's flux, magnetic flux B times
feels
area.
like area just charge.
Did we play 2 Christmas games yesterday?
Yeah,
What is
It's like a
If
solid
you can
one.
call it magnetic.
Wait, are you gonna be here tomorrow?
Magnetic.
Okay,
Let's.
let's play the other Christmas game tomorrow then.
What is
Yeah, I
Christmas?
think it is.
Because tomorrow's lecture is pretty short.
It is a charge.
Okay, let's just go to lunch then.
Yay!
Yeah!
R squared, right? So R squared.
Josh, you're getting girls to computer.
You are building
Yeah, I
a
am
partial.